Hi all, am I audible? Hello all, am I audible? All right, great. So let me share my screen. Right, let me open up Anaconda Navigator and I'll share my screen shortly. Cool, so I've opened Anaconda Navigator. I'll be sharing my screen shortly, don't worry. Cool, so let me share my screen. Alright, cool. So hi all, am I audible? Am I audible? Alright, cool. Good morning, Shalya. All right, people are joining in. All right, great. Yes, we'll do some project related to linear regression. Is my screen visible? Is my screen visible? Is my screen visible? Okay, cool. Let me work on sharing my screen first. Is it visible now? Is it visible now? Is it visible now? A Jamboard screen. Okay, great. Cool. Yes, the project will be discussed, don't worries. Okay, people are joining in. Let me do one thing. Yeah, I'll zoom out. Let me do one thing. Give me 1 second. I'll start shortly. Let me just copy the link. Give me a moment. All right. Excuse me. Let me just copy the link. All right, cool. Just give me 1 second. Let me bring in a few more people. The screen will start pretty soon. Screen will start pretty soon. Let me bring in few more people. I'm sorry, the session will start pretty soon. My entire screen is visible. Just give me 1 second, guys. Cool. Great. Alright, cool. So, how to draw a scatter plot of one variable? A scatter plot is basically what? A scatter plot is not a univariate analysis. It is basically bivariate analysis. Alright. So, a scatter plot is basically it can be drawn for two variables only. Alright. So, this is what it is. Alright. Cool. Cool. So, let us do what? Let us basically begin with our linear regression problem. I hope my screen is visible. Yes, it is. It is visible, I guess. Is my screen visible, guys? The linear regression part. Is my screen visible? All right, cool. So let us do what? Very pretty soon I'll be hosting a hypothesis testing and all the statistical functions that are in basically stats curriculum, basically hypothesis testing, chi-square test, your p-value definition, and your t-test, and a two-tail test, your two-tail test, and three-tail t-test, like that. So we will be discussing that as well very soon in the next weekend or maybe this weekday. All right, cool. So let us start with what. So as said earlier, said yesterday, that we will be discussing linear regression. So here it is. Here is your linear regression basically. All right. So let us begin linear regression. All right. So linear regression is what? So linear regression is what? Linear regression is our first ML algorithm. All right. Linear regression is our first ML algorithm, and it is what? It is basically your based on an equation of a straight line. It is basically based on an equation of a straight line. All right. So what I'll do is that I'll basically draw an equation of a straight line. All right. So just let me draw it once again. All right. So this is your y-axis and this is your x-axis. All right. That's your y-axis and that's your x-axis. Now I'll do what? I'll draw a straight line. So this is what it is. All right. And now the equation of the straight line is what? Equation of the straight line is y is equal to mx plus c. Y is equal to mx plus c. All right. Y is equal to mx plus c. Now please listen very carefully as to what it is. Basically x is what? X is your independent feature over here. X is your independent feature over here. Or as we call it as what? Column. Independent feature or column. We also call it these columns as what? We also call these columns as parameters. Also, all right, we also call these columns as parameters. So this is what it independent feature column. Basically, the columns based on which we define our define or predict our target variable or target feature or target column or target parameter. Now over here, y is our what? Y is our target parameter or target feature. All right. So this is what it is. Y over here is what? Is our target feature column parameter or variable also. So this is what it is. All right. And as you all must be aware, those who have studied maths in 10th, 11th, and 12th, this is what? This is your slope. This is your slope. This is your slope. And this C is what? C is your intercept. C is your intercept over here. C is your intercept over here. Now intercept is what? Intercept is the one that cuts the y-axis. The one that cuts the y-axis is equivalent to your what? Is equivalent to your intercept. And it will be equal, it won't be equivalent to any coordinate. It is a 1D value, one dimensional value. It will be equivalent to the y coordinate where the line is cutting the intercept. And of course, this is what? This is your straight line and this is the slope. M is your slope. So that is what linear regression is all about. So based on these independent features, basically your columns, it does what? It basically predicts the y, that is your dependent feature, target feature or parameter. All right, just give me 1 second. So this is what it is, parameter. All right, this is also known as what? This is known as dependent variable or dependent feature column parameter. Dependent feature, dependent feature. All right, the one that we predict. All right, any doubts anyone has still here? Is my voice clear? Is my voice clear? Okay, let me zoom out. Is my voice clear? All right, cool. Thanks a lot. All right. Yeah, I think I've zoomed out my screen. I think it is pretty visible what I have written. All right. Any doubts in the linear regression part? Any doubts in the linear regression part? Anyone till now? All right, cool. No doubts. Great, great, great. All right. Don't worry, project I'll discuss during the next weekend or this weekday. Don't worry about that. The project will be solved. Don't worry about that. All right. So this is what it is. All right. So once again, let's revise. So this is what? This is the y-axis, x-axis. This is the your straight line, and the equation of straight line is what? Equivalent to y is equal to mx plus c. Linear regression is based on what equation? Linear regression is based on the equation y is equal to mx plus c, where y is your what? Dependent feature, target feature, column or parameter. X is what? X is your independent feature. That is independent. We don't have to predict X features. We have to predict Y features. What the rows, the basically values of Y. All right, Y as a column, and X is what is the independent column. We don't have to predict. We have to keep it in the independent side, which we'll see when we implement the program. C is what? Intercept, one that cuts your uh, y-axis. All right. M is what? M is your slope. So this is what it is. All right. Now, how to calculate the slope, how to calculate the C. So let us move on towards the next slide. Let us move on towards the next slide and talk about how to basically check the basically how to calculate the slope and how to calculate the intercept. So this is what it is. All right. All right. So let us take the formula of M. Let us take the formula of M. Now, what is the formula of M? The formula of M is summation of x minus x bar, summation of x minus x bar into y minus y bar. Alright, that is what the formula of M. M is what? M is our slope of straight line divided by N. Summation of x minus x bar into y minus y bar divided by N. That is what the formula of slope is. I hope you all have a pen and paper in hand. Alright. If you don't have, please grab a pen and paper in hand so that we are able to do what? We are able to calculate, we are able to note down the formula. Alright, so this is what it is. Summation of x minus x bar into y minus y bar. Alright, so let us do what? Let us basically take two features. Let us take x. Alright, let us take y. Alright, let us take two features. Alright, let us take small values. We won't take lots of value. We'll take, let's say, 1, 2, 3. Or let us, alright, and we'll take 2, 1, 2. Alright. So this is what is, we've taken two features. We've taken three number of rows. What we'll do next is that we'll basically calculate the x minus, according to the formula, we'll calculate x minus x bar. Alright, we'll calculate what? We'll calculate x minus x bar. Now x minus x bar will be what? What is the mean of x? The mean of x is basically 1 plus 2, 3. 3 plus 3 is equal to 6. So 6 divided by 3 is what? 6 divided by 3 is your equivalent to 2. So that is what x bar is. Alright. We'll calculate y bar a bit later on. So 1 minus 2 is equivalent to 1 minus 2, that is x minus x bar, is equivalent to what? Is equivalent to minus 1. 2 minus 2 is equivalent to 0. 3 minus 2 is equivalent to 1. Alright. Now the formula says what? Y minus y bar. Alright. Y minus y bar. Now let us calculate what? Now let us calculate the mean of y. Alright. So mean of y is what? 2 plus 1, 3. 3 plus 2, 5. 5 divided by 3. Now 5 divided by 3 is what? 5 divided by 3 is your equivalent to 1.67. Alright. 1. Let's say 67. So this is what it is. Alright. Now 2 minus 1.67 is equivalent to what? It is equivalent to 0.33. Alright. It is equivalent to 0.33, followed by this 1 minus 1, it is equivalent to 1 minus 1.67 is equivalent to minus 0.67. Minus 0.67. Alright. Next is your 2, again same 0.33. Now we'll be needing a bit of calculator over here. Next we'll do what? The formula says summation of x minus x bar into y minus y. So what we'll do is that we'll basically let us take this as 1. Let us take this as 2. We'll multiply 1 and 2 and compute its summation. Alright, so that is what happens in the backend. Alright, so this is what happens in the backend. Alright, so 1 into 2. Alright, any doubts still here? Anyone has any doubts still here? Any anyone any doubts still here? Alright, cool. No doubts. So let us do what? Let us move ahead further. Alright, so 0.33 into so what we'll do next is that we'll basically multiply these two. So 1 minus 1 into 0.33 is equivalent to what? Minus 0.33. Alright, and it will be 0. So 0.33 into 1 will be 0.33. So the summation will come out as 0. So our slope will be what? If this is 0, our slope will also be equivalent to 0. 0 by 3, our slope will be equivalent to 0. So basically if we change a few values, let's say we change this to let's say 2, 2, 2. If we change the values, let's say 2, 2, 2, then the values will be a bit different. So alright. So that's how the slope gets calculated. And then we do what? We basically put the value of m into this, and then we calculate our into this equation, and then we calculate our c. Now how do we do that? We do that with the help of y bar is equal to mx bar plus c. So this is what it is. So y bar is your mean, x bar is what? X bar is your mean 2, and m is what? M is your slope, that is 0. X bar is what? X bar is your equivalent to 3. Alright, so this is what it is. Alright, just give me 1 second. I'll be back. Alright, cool. 0.3 into basically, sorry, 0.3, I'm sorry. 0 into 3. Not, it was not 0.3, 0.3, it will be 0 plus c, and y bar is what? Y bar is equivalent to 1.67. So c will be automatically equivalent to 1.67. So this is what it is. C will be automatically equivalent to 1.67. So this is what it is. So that's our intercept. So at the value of y, that is 1.67, it will cut the intercept and make a straight line. Alright. So this is what it is. Any doubts anyone has in the formula of slope? Is my voice clear? Isn't m y2? No, m is not y2 minus y1 upon x2 minus x1. Nope. This is the formula of m. Summation of x minus x bar into y minus y bar divided by n. So that is what the formula of. Is my voice audible? Is my voice breaking? I don't think so. Hello. Okay, I have a little background sound. Okay, okay, okay. Cool, cool, cool. Background sound. Okay. Let me give me 1 minute. Give me 1 minute. Give me 1 minute. All right. Is my voice clear now? Is my voice clear now? Any disturbance in the headphone? Hello, is my voice clear now? Okay, cool. Project deadline. Okay, cool. I'll connect with you all after the session, and then I'll basically discuss what it is all about. All right, cool. Point 33 is what I was talking about. Yeah, so any doubts in the calculation of slope, any doubts in the calculation of um, intercept, any doubts over here? How it gets calculated? Any doubts anyone has? How it gets calculated and all? Anyone has any doubts regarding slope? No doubts. Okay, cool. So shall we move ahead further? 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 Okay, cool. Cool, cool. So let us move ahead further. So this is how a linear regression gets calculated. All right, in the back end, of course. And next we'll do what? Next we'll basically discuss. Next we'll discuss what? Next we'll discuss the performance parameters, the performance metrics of linear regression. All right. Next we'll be discussing about the performance metrics of linear regression. So let us discuss what performance metrics. Performance metrics for linear regression. All right, cool. So we have multiple basically performance metrics for regression based problems. So I'll discuss a few of them. Basically the most important ones that are used in the day-to-day life of a data scientist or an AI/ML professional. All right. So first performance metric we'll be discussing is MSE, that is your mean squared error. Mean squared error. All right. First performance metric that we'll be discussing is your mean squared error. Now, before we discuss what is error, what is mean square error, or what is uh, basically MSE or any other basically your performance metric, let us discuss what error is first. Let us first discuss what is error. Error in regression analysis is also termed as what? It is also termed as residuals. Error in regression analysis is also termed as what? Is also termed as residuals. All right. Now residual is what? All right. Let's have a look at what residuals are. So residuals is your the actual value minus the predicted value. All right. The actual value minus the predicted value. Now let me label this actual value minus the predicted value. This y hat is what? This y hat is our predicted value. All right. So this is what it is. All right. Now, how do we calculate the predicted value? How do we calculate the predicted value inside these three data points? Let us have a look at that. Let us have a look at that. Let me create one more slide in between. Let us have a look at that. All right. So we created till what? We calculated till what? Summation of x minus x bar into y minus y bar. All right, we calculated a C which is equivalent to 1.67. All right, but now let us do what? Let us calculate the predicted value. All right, so the predicted value, I'll make a separate column for the predicted value, that is y hat. That is what? That is y hat. All right. So y hat equivalent to what? Now for the predicted value, for the predicted value, for the predicted value, slope and intercept will remain constant. For the predicted value, slope and intercept will remain constant. Alright. So this is what, let me write it over here. For the predicted value, slope and intercept will remain constant. Alright. So this is what it is. Cool. Next, let's calculate our predicted value. So it will be what? Mx1 mx1 plus c, all right, or mxn plus c, all right. Let me write it once again. Mx1 plus c or mxn plus c, whatever the value of x is, x1 x2, this is x1, this is x2, this is x3. So that is what will be our predicted value. The value of x will keep on changing. So let us do what? Let us create a column and calculate the predicted value. Now 0 into m is what? 0. 0 into x1. x1 is what? x1 is your basically 1 plus c, that is your 1.67. So whatever be the predicted value, whatever our predicted values will be, because our slope is 0 over here in this case, it will be what? It will be equivalent to 1.67. So it will give us what? It will give us the same predicted values. So this is what it is. Now that is why we talk about the uniformity of data. That is why we talk about the uniformity of data. The data should be diverse. The data should be widely spread. All right. In 3 rows of data, in 3 data points, it is very tough to find out a prediction. So we need at least 5 or at least 10 rows of data set. So I did only 3 data points. So in order to reduce the time of explanation and calculation. All right. So this is what it is. All right. So let us move ahead further. So it will give us 1.67, 1.67. So that is what our predicted value. So our entire predicted values, let's say this is 1.67. All right. X is 1.67 and I'm sorry, X is, let's say, just a second. X is 1. All right. And 2 and 3 and Y is, let's say, 1.67. Our data will be what? Will be flattened. It will create only this value. This is not a diverse set of data. It will create only these predictions, these 3 predictions. So we need a large data set in order to get better insights. Remember, if m is 0, then there's no point of applying linear regression. All right, so this is what it is. So moving ahead further, so that's how we calculate y hat. Now if we calculate the residuals of this case, let's say y minus y hat. So what will it be? Y minus y hat, y minus y hat, just a second. All right. What will it be in this case? It will be 0.33. All right. So this is what, and so on. All right. 0.33. So that is how residuals are calculated. That is how errors are calculated. Errors or residuals are what? Difference between difference between the actual value and the predicted value. That is what your error and residuals represent. That is what your error and residuals represent. So this is what it is. All right. Now coming back to the point of what mean squared error. Coming back to the point of mean squared error. Anyone has any doubts still here? Is my voice clear? Anyone has any doubts still here? Is my voice clear? Any doubts still here? Anyone? All right, cool. Is my voice clear? All right, great. Just give me 1 second. All right, cool. Let us talk about what? Let us talk about mean squared error. All right. So mean squared error is what? MSE. It is represented, of course, it is represented as MSE. But what is mean squared error? So basically, mean squared error is what? Mean squared error. The error, square that error. What is error? Error is our, or residual is our what? Y minus y hat. Y hat is what? Y hat is a predicted value. Y hat is a predicted value, and mean and square of it, of course. Square of it. And mean is what? Mean is summation. Summation of that particular, let's say, feature. It is a feature. It will be calculated one by one, y minus y hat, and divided by the n, divided by the number of row entries we have. So that is what mean square error is all about. How we calculate mean? Let's say we have mean x. You want to calculate of mean of variable x. So how we calculate? Summation of x divided by n. So that is what is square, mean, and your error. That is what mean square error is all about. So it is what? It is another performance metric of what? It is another performance metric of your linear regression. All right. It basically tells how diverse your data is spread, and what correct prediction your linear regression algorithm is giving or not. Now, the range, I'll go it in a bit more detail. The range of MSE is what? Minus infinity to plus infinity. Minus infinity to plus infinity. That is what the range of MSE is. Minus infinity to plus infinity. Now, if it is greater than 0, or if it is positive, then we'll say that our predictions are more towards the positive side. The values are more towards the positive, and there is what? There is less diversion. Less diversion, that means less outliers in our predicted values. Less outliers, less diversion in our data, more uniformity, and there are less outliers in our data. All right. But if there is a, let's say if it is highly positive, mean square error is highly positive, then we'll say there are more number of outliers in our data, more large number of values in our data. The data is said to be what? Not very diverse. So it should be closer to zero, or it can be up to 15, 20 as well. It should not be very highly positive. And at the same time, it should not be very highly negative as well, because there is a concept known as negative outliers as well. There's a concept negative outliers as well. So that is what it is. All right. And that is what mean squared error represents. All right. Any doubts anyone has still here? All right, cool. So let us move ahead. Let us talk about what? Let us talk about your RMSE. RMSE is what? Root mean square error. Again, same concept, but a different, a similar formula, but only a under root is added. That's it. All right, summation of y minus y hat. All right, summation of y minus y hat. Y hat is what? Our predicted value. Y is what? Y is our actual value divided by n, whole under root. Whole under root. So this is what? Same concept, ranges from minus infinity to plus infinity. So this is what it is. And it is represented as what? It is represented as RMSE. It is represented as RMSE. Alright. Moving ahead further. Moving ahead further. Talking about what? Talking about the most important metric, and the most considered metric of all time in a regression analysis, which is what? Which is your R square. The most important metric of all time, which is your what? Which is your R square. Alright. Cool. Any doubts anyone has till now? Alright, cool. Moving ahead further, let us talk about what? Let us talk about R square. Alright. If any doubts, please feel free to ask. If you have any doubts, please feel free to ask. Cool. Alright, moving ahead further, talking about R square. Alright. R square, or we also call it as R2 score. We also call it as what? We also call it as R2 underscore score. So this is what it is. Next we'll do what? Next we'll basically discuss the formula of R square. Right. It is very simple. 1 minus what? 1 minus SSR. Alright. SSR divided by SST, or we call it as TSS. Alright, we call it as TSS. Now, what is SSR? What is TSS? Let us discuss that. So, SSR is equivalent to sum of squares of residuals. Sum of squares of residuals. Alright. What is sum of squares of residuals? As we discussed, this is our basically summation of squares of residuals. Alright. Alright. Summation of squares of residuals, which is equivalent to what? Which is equivalent to summation of y minus y bar. Summation of y minus y bar. I'm sorry, y minus y hat. Y minus y hat whole square. So this is what it is. Alright, y minus summation of y minus y bar, y minus y hat, y summation of y minus y hat whole square. Alright, cool. Next we'll talk about what? Next we'll talk about your TSS. TSS is what? TSS is your total sum of squares. TSS is what? Total sum of squares. So this is what it is. TSS is your total sum of squares. Right. Now that is what summation of y minus, this is summation of y minus y bar whole square. Summation of y minus y bar whole square. So this is what your R square is. It basically calculates what? It basically calculates your performance metric of linear regression. Alright. Now let us do what? Let us discuss what R square is all about. Let us discuss what R square is all about. Okay. The range of R square is what? Please listen to this very carefully. Please listen to this very carefully. Alright. Alright. So R square ranges from R square or R2 score ranges from what? Ranges from 0 to plus 1. Alright. 0 to plus 1. R2 score ranges from 0 to plus 1. Now that means what? That means it is probabilistic in nature. It is probabilistic in nature. The basically your the limitations of probability, the limitations of probability is what? Equivalent to the range of probability is equivalent to what? Please write it in the live stream chat. Please write it in the chat. What is the range of probability? All right. Yes, correct. It is 0 to plus 1. 0 to plus 1. Absolutely correct. Shalya Gandhi, Dhanshriya Sai, Vaibhav Bhagat, AK, Akhil Raj. Absolutely correct. 0 to plus 1. Rishabh Paul. Absolutely correct. The range of probability is 0 to plus 1. So this is what it is. Alright, so that means R2 score is what? It will always be positive, and the greater the R2 score is, the greater the R2 score is, that means the more it is closer to 1.9, 0.7 or zero point 0.8 like that. So we'll consider that our linear regression model is well trained. Alright, let me write the formula, the expanded version of the formula. Alright, so R2 score is what? R2 score 1 minus summation of y minus y hat whole square divided by summation of y minus y bar whole square. Alright, y minus y bar whole square. So this is what the expanded formula of R2 score is. We don't in case of R2 square, basically R square, R2 score, we don't keep that score and send it on the right hand side. We don't do that and keep it as under root. No, we don't do that. In this case, we don't do that. Why? Because we need to calculate the metrics which are equivalent to which range from 0 to plus 1. Because we want probabilistic values, so R square is more accurate as compared to a singular R. So we will always use what? R square. Alright. So this is what it is. Alright. Now moving ahead further, talking about what the range. So the closer it is to plus 1, it is to plus 1, let's say, a point 0.7, point 0.8, point 0.9, etc. The better the better the model score or accuracy of our regression model or analysis. Alright, so this is what it is. The closer it is to 1, let's say 0.7, 0.8, 0.9, the better the model score or accuracy of our regression model or analysis. So this is what it is. It is very much useful and the most preferred metric, performance metric, whether you are giving an interview, and this is very, very important. This is very, very important. VVIP or VVIMP. If the question relates to what? If the question relates to linear regression, if the question relates to regression analysis in the interview, always expect this question to be asked, and I expect all of you to answer this. So this is what it is. Once again, I'm saying it is very, very important. Right. So this is what it is. R2 score ranges from 0 to plus 1. The range of probability 0 to plus 1. That means it is probabilistic. This is its formula. 1 minus sum of square divided by total sum of squares. Alright. So this is what it is. And the closer it is to plus 1, we'll say the better trained our model is. Our regression model is. So that is one of the most important performance metrics according to the according to the interviewer, because it is, if it is regression analysis and if the question of linear regression gets popped up or any regression analysis gets popped up, let's say random forest regressor, decision tree regressor, then be prepared to ask this question or be prepared to answer this question. All right, which is R2 score. All right, cool. So any doubts in R2 score? Any doubts in R2 score? Okay, so in the interview, they will be asking what? They will be asking firstly about your introduction. So you need to give introduction according to what you've done in data science and machine learning. All right, that is what the introduction you will give. All right, and give introduction according to what projects you've done. All right, what projects you've done, give introduction according to that. है ना? And whenever you whatever project problem statement you tell, the interview will be directed from there. If you talk about a regression, I did a regression problem, performed linear regression. The accuracy of that model was, let's say, 0.75, a good accuracy. And I measured the accuracy with the help of R2 score, like that. And from there onwards, the directive of the interview will go forward, and there onwards, they will check your knowledge about certain regression problems, linear regression, like that. So You should, while discussing the project, while telling your project to the interviewer, discuss, first thing you need to tell is discuss the source of data. From where did you find the data source? Mention Kaggle, mention UCI machine learning repository, like that. So this is what it is. All right. Uh, all right. So let us move ahead further. Let us talk about adjusted R square. Hi Raghav, how are you? Cool. Raghav is my very old friend uh, from college days. Cool. So let us talk about what? Let us talk about adjusted R square. Let us talk about adjusted R square. What is adjusted R square? Okay. So let us talk about adjusted R square. So adjusted R square. So we'll firstly do what? We'll firstly discuss the mathematical implementation of adjusted R square. We'll firstly discuss the mathematical implementation of adjusted R square, followed by basically the formula of adjusted R square, followed by what? Followed by why it is used, na? Why it is used, and why is it preferred over R square. Alright. So this is what it is. So let us discuss the formula of adjusted R square. So it is 1 minus what? 1 minus, right? 1 minus R square. Alright. Followed by n minus. Am I audible? Am I audible? Am I audible? Alright, cool. There is a power cut at my place. There is a power cut at my place. That's why I got disconnected for a while. Alright. So this is what it is. Alright, cool. So this is what the formula of what adjusted R square is. This is what the formula of adjusted R square is. The formula of adjusted R square is. Alright. Where R square is what? R square is your again performance metric. Alright. R square is your performance metric. Alright. And N is what? N is the number of rows. And P is what? P is your population sample. Alright. P is your population sample. Alright. Basically, what is population sample? Your number of rows in test data. Number of rows in test data, and N is what? N is your total number of rows. Total number of rows. I'll basically discuss only in layman terms. I won't use technical jargon so that it goes above the head of most of the people. So population, P is what? Population sample, that is number of rows in test data, and N is what? N is your total number of rows. N is your total number of rows. So this is what it is. Alright. So this is what N is what? N is your total number of rows. Alright. Cool. So let us do what? Let us discuss further. Now why adjusted R square is used over R square. So again, this is a very important question. Very, very important question. Why adjusted R square is used over R square. Now, firstly, it has diverse set of values as compared to R square. It has diverse set of values as compared to R square. Why? Diverse set of values, or I'll say diverse range as compared to R square. Diverse range as compared, it ranges from -1 to +1. Alright, it ranges from -1 to +1. So the interviewer will definitely ask you why are you not using, why are you preferring adjusted R square over R square if it comes to regression analysis. Alright. So this is what it is. R square is your adjusted R, the R square that we calculated, alright, that we basically discussed in the previous slide. Alright, R square is basically which we discussed in the previous slide. Alright, so this is what it is. Alright, so this is your total number of, so P is your population sample. Alright, and R square is your R square that we calculated previously. Alright, it ranges from -1 to +1. Alright, let us move ahead and talk a bit further. Alright, let us talk a bit further about what adjusted R square -1 to +1. Alright, and whatever, let's say it is a live data. Let's say it is a live data, and we are doing what we are basically we have calculated R square, and it is a live data. We are adding more data points. We are adding more data points in Y. We are adding more data points in the dependent feature Y. Then what happens? R square diminishes when we add. Let me write it down. When we add more data in the dependent feature, the value of R2 score diminishes. Diminishes. The value of R2 score diminishes. Alright, it diminishes. Alright, whereas whereas the value of adjusted R2 score remains stable or improves. Whereas the value of adjusted R2 score remains stable or improves. Alright, so this is what it is. Alright, so this is what it is. Alright, so that's why we use adjusted R score, and it has a diverse range -1 to +1. Alright, so these are the two properties. Let us discuss the third more important, very important property of adjusted R square. It is always nearer to R square. It is always nearer to R square. This is the third property of what? This is the third property of adjusted R square. Adjusted R square is always nearer to R square. The fourth property, it is always less than R square. It is always less than R square. It is always nearer or closer to R square, and it is always less than R square. It will never be greater than R square. It will never be greater than R square. So this is what it is. So these are the four different properties of adjusted R square. It has diverse range as compared to R square. It ranges from -1 to +1. When we add more data in the dependent feature, the value of R square reduces, whereas the value of adjusted R square improves, and it remains stable mostly. But the third and fourth property basically puts rest to all the other arguments. That is what, it is always closer to R square but less than R square, which means it is more stable and more accurate. So this is what it is. So this is what it is. All right. Cool. So any doubts anyone has? All right, cool. So this is what adjusted R square. So this is what linear regression is all about. So this is what a linear regression is all about. We have a linear regression which does what? Which basically calculates, which is basically based on a straight line equation of straight line. All right. It does what? It basically calculates the m based on this formula. All right. It does what? It basically calculates your c intercept. It does what? This y is what? This y is a target feature, in basically target feature or dependent variable. All right, this X is your independent feature. All right, and C is what? C is your intercept, the one that cuts the y-axis. We have certain performance measure. We calculate errors, we calculate residuals, or y minus y hat, which is actual the difference between actual value and predicted value. All right, we have performance metrics for linear regression. All right, MSE, RMSE, but the most used performance metric is what? R square, followed by your adjusted R square. R square ranges from 0 to plus 1. All right, if it is closer to 1, better our model. And adjusted R square is what? Minus 1 to plus 1. This comparison between R square and adjusted R square is asked a lot in the interview. The comparison between R square and adjusted R square is asked a lot in the interview. So this is what it is. Very, very important. Very, very important. Alright. So let us do what? So this is what linear regression is all about. Let us do what? Let us start with what? Let us start with the topic linear regression. Alright. Let us start with the topic linear regression and let us do what? Let us solve a project. Alright. Let us solve a project on linear. Let us apply linear regression. Let us take a data. Let us import the necessary libraries. Let us such as pandas as pd, numpy as np. Alright, df is equal to pd dot read underscore csv. We can also do what? We can just directly copy the path of the application. Alright, we can directly copy the path of the application. Let me just find weather.csv where weather.csv is. Alright, path. So this is what R is what R is a Unicode character and followed by single inverted quotes and basically just copy the path of what path name of your file. You don't need to upload it in the Jupyter notebook, just copy the path and just simply run it. So this is what now it is showing what it is showing us a warning. Basically it has mixed data types, no worries. We can do what we can basically import filter warnings, ignore. So this is what check for df.head. Alright, check for df.tail, basic data analysis. Df.head will give you what top 5 rows, df.tail will give you what for df.info. Basically it will give you what data types of the range index of the basically rows, rows and of course the columns as well. 30 columns, it has data types of all the features, all the columns. Alright, uh, df.describe, etc, etc. EDA we will be discussing in an other part. Alright, we will be discussing, let me repeat it once again, we will be discussing EDA in another session sometime. EDA and data pre-processing. Alright, that is involved in what? That is involved in machine learning algorithms. Alright, now talking about what? Now we'll talk about just a second, let me adjust my screen. Alright, now we'll talk about basically defining our independent features. Defining our independent feature, defining of independent features. Defining of independent features. Is my screen visible? Is my screen visible? Alright, cool. So let us do what? Let us define independent features. Alright. We'll do what? We'll basically independent feature. Now how we'll define the independent features? We'll take up a problem statement. Alright. So problem statement. Problem statement will be what? Alright, we'll basically discuss what? We'll discuss the problem statement first. So we have in our data set what? We have our max temp, we have our min temp. In our data set, we have what? We have our max temp, we have our min temp. Alright. So what we'll do is that we need to, given max temp, given maximum temperature, we have to do what? We have to predict minimum temperature. Given maximum temperature, we have to predict minimum temperature. Alright. So what we'll do is that we are given maximum temperature, we have to do what? We have to predict minimum temperature. This is what we have to do. Alright. Alright. Given what? Given maximum temperature, we have to predict minimum temperature. Alright. So this is what our problem statement is all about. Alright. So maximum temperature will come where? Where maximum temperature will come in your independent feature. Maximum temperature will come in your independent feature. Alright. Which is equivalent to what? Max temp over here. Which is equivalent to your max temp over here. Alright. Now we are taking only singular variable. Now we'll do what? We'll basically define independent features. Defining of the independent features. Alright. Uh, is that clear? Are we on the same page? Are we on the same page? Are we on the same page? Okay, cool, cool. Alright. So defining of the independent features. So what we'll do is that y is equal to df of min temp. Alright. So let us define what? Let us define the independent features. Alright. So now as we are taking only singular variables, alright, we are taking only one variable. So machine learning algorithm does not accept one variable in the independent feature. Alright. As a data frame or as a series, machine learning algorithm does not accept uh, a singular feature in what? In a series or a data frame in independent feature. Alright. So this is what it is. So what we need to do is that we need to convert that into an array. We need to convert this into an array. Alright. So we will convert, but we will see once. We will see once what we will see what we will train our model and it will result in an error. I'm repeating it once again, please listen to this very carefully. We will train our model and it will result in an error. Why? Because I haven't converted it into an array. Why need to convert it into an array? Because I need max temp, because it is one independent feature. Machine learning algorithm does not accept one independent feature. It needs to get converted into an array, and of course the dependent feature also to get converted into an array. So this is what if there are singular independent features. So let me train the model. Firstly, we'll do what? We'll basically apply the train test split. Train test split. Train test split x underscore train comma x underscore test comma y underscore train comma y underscore test. Alright, train underscore test underscore split x comma y, which we have defined already. Test underscore size is equal to zero point 0.3 comma train underscore size equal to 0.7. If we don't write train underscore size, it will automatically split the train size to 70%. 70-30 ratio, right? So this is what is random underscore state is equal to 1. Random state defines what? Random state defines the level of randomness the data has been splitted. So the data that gets splitted in the train test split, that gets splitted randomly. Alright. So this is what if we increase the value, it will increase the randomness, splitting of randomness. So we do not need to increase the value of random state. We need to keep it at 1 only. So this is what it is. So that like values are splitted in x train x test and y train y test. So this is what, alright. So it says train test split not defined. So let us define import train test split. Train test split function. from sklearn dot model underscore selection import train underscore test underscore split. Alright, so this is what it is. Now it will run fine. Alright, so we have done what? We have splitted our data. Let's check the shape of our data. Xtest dot shape y train dot shape y underscore test dot shape. Alright, so we have splitted our data. Alright, now what we'll do is that we'll import linear regression from sklearn. Alright, if you want to know more about sklearn, just go to what? Go to sklearn's documented website, documentation, official documentation, and you can know more about the other algorithms that are currently in work. Basically, this also gets updated a lot. So you can visit to scikit-learn.org and you can basically know about if you are more into research, we want to get into more research based work, you can basically visit this website, which is scikit-learn.org. All right, cool. So let us move ahead. Let us move ahead further. All right, let us move ahead further. All right, the power is back. Let me import linear regression. Import linear regression. All right. So as I said, now we'll do what? We'll create the object class of linear regression. This is what? This is the object class of linear regression. All right. Next, we'll do what? We'll train the model using dot fit function. Train the model using dot fit function. So lr dot fit x underscore train comma y underscore train. Now, as I said earlier that it is be prepared that it will result in what? It will result in an error. Why? Because machine learning algorithms of sklearn do not take data frame, a singular data frame or series in an independent feature. They take multiple data frame or series in the independent feature. So be prepared for an error. So this is what it is showing. So we need to convert it into what? We need to convert it into data and reshape it from 1D array to minus 1 comma 1. So it already says expected a 2D array. Here it is what it is. Here it is all singular dimensions. So now what we need to do is that we need to convert it into array and reshape it from minus 1 to 1. Same for this dot values dot reshape minus 1 comma 1 and rerun the entire thing. Now as you can see, our model is pretty well trained now. Our model is pretty well trained now and it is showing what? It is showing that it has trained the model, it has trained it on the patterns of what? X train and Y train, the one that we splitted it above. Now to predict the model, what we'll do is that what we'll do is that we'll basically take up a variable lr underscore pred. Lr is what? The object class of regression which we trained. All right, and it has taken all the trained parameters, the trained features in lr. Now we'll predict with the help of lr. We'll predict the test data. X underscore test lr underscore pred. Now these are what? These values are your min temp predicted values. Basically what? Y hat. Alright, y hat is what? Y hat is your predicted value and min temp is what? This y is your what? This y is your actual value. Now what we'll do next is that we'll basically calculate the R2 score. Calculate the R2 score. To basically measure the accuracy. Measure the accuracy. Now let us measure the accuracy over here as well. Accuracy of trained data. We'll do what? We'll take lr dot score x underscore train comma y underscore train. Alright, it is giving an accuracy of what? 0.77. That is 77%. Let us check the accuracy of what? Let us check the accuracy of test data. So it is giving us an accuracy of what? Let us check x test, comma, y underscore test. So it is giving an accuracy of 76%. Now this test accuracy is equivalent to R2 score. This test accuracy is equivalent to your R2 score. Now let us do what? Let us calculate the R2 score from sklearn.metrics import R2 underscore score. Alright, next we'll do what? We'll basically calculate the R2 score. Alright, which is y underscore test, comma, y underscore pred, which will give us the, I'm sorry, y underscore test, comma, lr underscore pred. You've taken lr underscore pred as our y hat. Alright. So it will give us what? It will give us the same value, which is 76%. As you can see, 76%. So either you write lr dot score, or either you write r2 underscore score. It is going to give us the same accuracy. All right. So this is what it is. All right. Any doubts still here? Anyone has any doubts still here? Anyone has any doubts still here? Anyone has any doubts still here? Anyone, any doubts? Okay, no doubts. Cool, 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 great. All right, very good. So this is how we basically do what? This is how we calculate the accuracy. Next, what we'll do is that next we'll calculate the adjusted R square. Next, we'll calculate the adjusted R square, or adjusted R2 score, as we can say. All right, we'll take now there is no such function for adjusted R2 score. There is no such function for adjusted R2 score. All right, so we need to do what? We need to calculate it from scratch. All right, we need to calculate it from scratch. Let us do what? Let us take R2 and let us store it in a variable as R2. All right, and let me do what? Let me remove 100. All right, R2 is 0.76. All right, let us take it like this. All right, and next we'll do what? Next we'll basically let's write R2 like this. All right, give me 1 second. Give me 1 second. All right, talking about the R2 score, 1 minus in brackets. Just look at this formula. All right, let me open the Jamboard once again. Jamboard. All right, just to look at the formula. कहाँ गया? Yeah, here is the formula of adjusted R. So we'll copy this very same formula and create its what? Create its Python implementation. All right. So 1 minus R2. All right. R2 is what? R2 is the score that R2 score that we calculate. 1 minus R2. All right. In basically asterisk followed by n minus 1. Now n minus 1 is what? N minus 1 over here should be our what? N minus 1 should be our number of rows. All right, number of rows. Now number of rows. How do we calculate number of rows? N is equal to df dot shape 0. So it will be equivalent to what? It will be equivalent to number of rows. So df dot shape is what? Df dot shape of 0. Df dot shape gives us rows and columns, but df dot shape 0 gives us what? The number of rows, and df dot shape 1 gives us what? The number of columns. All right, so this is what it is. All right, now what we'll do is that we've basically stored n in this n minus 1. All right, now whole divided by n minus p minus 1. Now over here, P is what? P is the number of independent variables in the test data. number of independent variables in the test data. Alright, P is equal to x underscore test. Alright, so this is what it is, x underscore test dot shape 0. Alright, so this is what it will, now P will be equivalent to what? 35712. Alright, let us calculate adjusted R2. So it is equivalent to 0.66. So that is, if you multiply it, 66%. So uh, it does justice to what? It does justice to our R2 score. All the properties of adjusted R2. It has diverse range of values, of course. Uh, it basically it is closer to nearer to R square, but always less than R square. Always less than R2 score. So this is what it is. All right. So this is what it is. All right. This is what linear regression is all about. All right. This is what linear regression is all about. All right. This is what linear regression is all about. All right. Any doubt? Any doubts anyone has? Any doubts anyone has in linear regression? Anyone has any doubts in linear regression? Whether adjusted R2 score or R2 score? Any doubts anyone has? There is a poll. Please fill the poll. Yeah, len df also is the correct. Len x underscore test is also correct. Absolutely correct. We can do with the help of that. Also, we can do with the help of this also. All right. So that's all we have for today's session. We'll meet next week or most probably this weekday. And don't worry about the project. Those of you who all are having doubts in the project, please connect with me on LinkedIn. I'll solve that. Don't worry about that. All right. Thanks a lot, everyone. See you all. Bye bye.